Okay folks, today we're looking at how to solve equations containing absolute values. Our whole theme for this chapter, we had a little isolated bit on roots at the beginning, and you're going to kind of find out later in the chapter the purpose for that. But our whole theme for this chapter is solving equations that have two solutions. Okay, so eventually we're going to work our way up to quadratics, and quadratic equations have two solutions, but we're first going to look at absolute values. So what is an absolute value? Well, first things first, it looks like this. It just looks like brackets, except kind of without the little straight lines there. It looks like two vertical lines next to each other. And what it does is when we put a number inside of it, it makes it positive. It returns the positive value of that number. Okay, so for example, if we were to take the absolute value of -3, we'd get 3. If we were to take the absolute value of +3, we'd also get 3, because 3 is already positive. So it takes any negative symbol, it takes any negative number that's inside of it and makes it positive. Now, the key is you do have to simplify first. Okay, so when we're actually trying to simplify these expressions, you need to simplify inside the absolute value first as if it's parentheses, and then make your final number positive. So check your understanding of this. Try evaluating B, C, D, and E here. Pause and then come back. Okay, for B, we already simplified down to one number, and it will turn that number positive and make it 2. C, also 2. It will take the number that's already positive and just keep it positive. D, this is tricky. You can't turn that -3 positive first. The absolute values also act like parentheses. That's why I said evaluate or simplify inside the absolute value first. So we need to add -3 to 5. Okay, and we get 2. And then we know the absolute value of 2 already is 2. The bottom here is a little different. 3 times 3 is 9, minus 11 is -2. So we simplify that all down to -2 first. Come back, boom, it's a 2. Okay? So now when we're solving absolute value equations, what we're going to find is that we have two solutions. So for A, I just kind of want you to try to think about it. What are the value or values for x that would make that equation true? Pause and think about this if you need to, but try to write down a guess. So we know that the absolute value of 2 would be equal to 2 from above, and we also know that -2 would give us 2. So that means our x can be 2, or x could be -2. Both of those solutions are correct. They work. So here's going to be the way that we're going to solve absolute value equations. We're going to use that idea. What we have to realize is that we have to do simplifying inside of absolute values first. So like what B means when we say absolute value of x plus 1 is 2, it means x plus 1 has to simplify to 2. If x plus 1 simplifies to 2, we'll get a 2. If it simplifies to -2, oops, sorry about that, that should be a 1, we'll get 2. So all you're going to do is take whatever's inside your absolute value and set it equal to the positive and to the negative version of that number. You're going to solve those two equations. This one gets us a 1. This one gets us a -3. And then we're done. That's it. Go ahead and check those answers if you'd like. Plug them back in. I'm going to actually plug back in the -3 here, and I'm going to see what I get. I get -3 plus 1, which is absolute value of -2, which is 2. And that's what I was supposed to get. This was supposed to be equal to 2. So what I want you to do is try, let's see, how many more do I get on here? C, D, and you know what? Even try the 2 on the back. Try C, D, and see if you can manage the 2 on the back. The 2 on the back are trickier, but try them anyway. If you don't get them, no big deal. Pause and then come back. Okay, for C, you're going to set 3x equal to 12 and a -12. Because if that little expression in there simplifies to either of those two numbers, you will get a 12 after you take the absolute value. divide by 3, and we get x is equal to 4 or negative 4. D, there's nothing really tricky here. It's just going to end up being multiple steps. We need to set it equal to 3 and set it equal to negative 3. We subtract 1. Here we get 2x equals 2. On our other equation, we get 2x equals negative 4. So we get x equals 1. And we get x equals negative 2. Woohoo! On to the tricky examples. We're back to the orange paper. I know, you're all excited. So for A, what most people think to do is they go, okay, well, 3x equals negative 6 and 3x equals 6. Here's the problem. Our basic equation says the absolute value of a number is equal to a negative 6. We can't take the absolute value of anything at all and get negative 6. We'd have to get positive 6. So this just simply can't be true. There's no solution here. The trick with B is that we can't just immediately say, we can't just set it equal to 1 and negative 1, and we can't eliminate it right away either. We don't have an absolute value by itself. You see, if you think about this, think of it this way. This really means something minus 4 is negative 1. I know that this could be a 3, right? Which is what I find when I add 4 to both sides. I get the absolute value of x is equal to 3. From there, I find that x is equal to 3 or negative 3. So the reason that B is tricky is because you have to isolate the absolute value first before you set it equal to the positive and negative value. So our two really odd cases, if you have an absolute value just by itself equal to a negative, you can eliminate that. That's no good, no solution. If you have an absolute value with other stuff around it, you can't set up two equations until you get the absolute value all by itself. That's it for this one. Try some practice problems, try a concept quiz. Good luck.